Hello, and welcome back to my math YouTube series. For those of you who don't know me, I'm Andrew, a local Bay Area tutor. I offer in-person and virtual tutoring, and I'm the one behind these helpful videos. Be sure to check out my website via the link in the video description below, and please give this video a thumbs up if you find it helpful. Now, on to today's subject, imaginary numbers. What are imaginary numbers? They're kind of a weird concept to wrap your head around, especially since math is very logical. Imaginary numbers are kind of used to describe non-real numbers, which sounds kind of obvious, but hear me out. Think of a parabola, especially on a graph. Some parabolas or other functions, without any real roots, so without any places where they intercept the x-axis, still have roots, but they just are represented with imaginary numbers. So I'll write that down here. Basically, they represent traditionally impossible real numbers. And again, parabolas and other functions without any real roots still have roots, they're just imaginary. So I want you to think about this because this is kind of central to the idea of what the imaginary number is. Think about this problem for a second and try to solve it. What is the square root of -1? Can't figure it out? You could try typing it into a calculator and see what you get. I'll do that here. Notice how I got an error message. And that's because you can't get a real answer by taking the square root of any negative number. And this is what imaginary numbers are and why they exist. So the square root of -1 will be equal to I. This is an imaginary number. Even though it's a letter, it's an imaginary number. So I is the mathematical solution to the square root of -1. So if I equals the square root of -1, then what does I squared equal? Think about that for a sec. Well, I squared is I times I, which is the same as the square root of -1 times the square root of -1, which ultimately equals -1. And then what about I cubed, or I to the third power? Well, that would equal I times I times I, which would be -1 times I, which would be -I. And then what about I to the fourth? Well, I to the fourth is I times I times I times I, which is I squared times I squared, which is -1 times -1, which would equal +1. So the interesting thing here is this kind of pattern, where it goes negative square root of 1, -1, -I, and +1 will repeat every I to the fourth, if that makes sense. I'll show you what this pattern looks like, and I'll highlight it so we can use this to simplify something crazy like I to the 37th or I to the 100th. Because if we know this pattern repeats every I to the fourth, then we can simplify, and I'll show you how. So let's take this and use this for finding out what I to the 37th would equal. So first, we got to think about, well, how many times does 4 go into 37? Because this pattern repeats every I to the fourth. And it turns out that it goes in 9 times with the remainder of 1. And the remainder is really what we care about, because it goes in 4 times, because 4 times 9 is 36. And then if there's a remainder of 1, that means it's going to go 1 further. So I to the 37th would equal the square root of -1, which is the same thing as I. I'm going to end with this pattern chart here for you. I recommend putting it into your notes. It's very helpful. Thank you so much for watching, and I'll see you next time.